Everyone, welcome to the class of physics for class 9, and as we were doing reflection of light, we shall continue with that. Okay, so in the last class we learned about the types of images, then we learned about the kind of image formed on a plane mirror, how the images are formed on a plane mirror. So today we will be discussing briefly about the characteristics of images formed on a plane mirror. Okay, characteristics of images formed on a plane mirror. So what do you mean by characteristics of the images formed on a plane mirror means what kind of image, okay, what is the character of the image, what kind of image and how does that image act, okay, what are the characters of the image formed on a plane mirror, okay, what are the qualities are, how is it formed on a plane mirror. So the first one is, you know that very well, the image formed on a plane mirror is virtual, and we've discussed this every now and then, that virtual means when the reflected rays, they do not actually meet, they only meet when they are produced backwards. And if it's virtual, then it will be erect, the image will be erect. So erect means if this is the object and this is the mirror, the image will be standing just like the object. Okay, if this is your mirror, image will be just like the object. So erect means upside only. Okay, it will not be inverse, means this way. It will be upside down. And erect means as it is, that is upright. Okay, it will be upright. Okay, the second one, as you can see, the distance of the object and the distance of the image will be the same. If it's 3 meters from the mirror, it will be 3 units from the mirror. That means the object distance and the image distance will be same. Okay. The second one is the object distance and the image distance will be same. Okay. Now the third one is the image will be laterally inverted. The image will be laterally inverted. Now what do you mean by laterally inverted? It means the phenomenon, okay, which we do in mirror, when we raise our left hand, the image raises its right hand. And when we raise our right hand, the image raises its left. So the phenomenon in which the left seems to be the right in a mirror is called lateral inversion. Okay, the phenomenon in which the right appears to be the left, okay, the right seems to be the left, the right appears to be the left, and the left appears to be right in a mirror is called lateral inversion. Okay, so we call the image to be laterally inverted. So you might have seen some of the, say this is your mirror, and say if you saw the word P, the letter P in a mirror, the image will be inverted like this, isn't it? It will be like this. This phenomenon is called lateral inversion. Okay, it is called lateral inversion, and we say the image is laterally inverted. And that is why, you have learned this in class 7 as well, that is why the ambulance is written in the reverse way, so that the driver who is in front of the ambulance, when he sees it through his rear view, okay, when he sees it through his rear view mirror, he would read it correctly and let the ambulance pass. Okay, the image will be laterally inverted. So image is virtual and erect. The object distance and the image distance will be same. The image will be laterally inverted. The image is formed behind the mirror. The image is formed behind the mirror. So these are the characteristics of the image formed on a plane mirror. Okay. So if you know this, if you see any image with this characteristics, you know that is the image formed on a plane mirror. And I'm sure you are very much aware of the images formed on a, you're already sure of the images formed on a, the uses of a plane mirror. The first use is we see, it is used to see ourselves, to groom ourselves every day. It is used in periscope. You know, this is a periscope where we see from here, and we can, with the help of periscope, we can see objects which are beyond our, reach to see with a naked eye. Okay, so if there are some obstacles and we cannot see images, we cannot see objects which are above it, then we can use periscope. Like in case of submarines, those submarines, they use periscope to see above the sea if there is any land or something, isn't it? So how does it work, a periscope? There are two mirrors which are inclined at an angle of 45 degrees, and the object, if any object is here, it will reflect the light, okay, and the light will be reflected. An image is formed here of the object. This image will act as an object for this mirror, and the image of this image will again be formed here. And with the eye we can see, with our eye we can see the object here. So this is how a periscope works. And then there is another one, a kaleidoscope. I'm sure you all have, you've done in your project work also, isn't it? I don't know how really people have done it or not. But then you make a hole over here, and then you put bangles. So when you see through this hole, you can see multiple reflection, you can see different designs. That is your kaleidoscope. Okay. This is called your kaleidoscope. And there are other uses also. The plane mirrors are used in the different shops, malls, isn't it? So these are the uses of plane mirror. Now another one is how the images are formed. Okay, what is the number of images formed when there are two mirrors, not just two mirrors, when there are two mirrors, or depending upon the angle. Okay, how the two mirrors are arranged, how many reflections how many images will be formed. And for that, say there are two mirrors which is kept like this. Okay, the two mirrors are kept like this, M1, M and M dash. See, there are two mirrors. One is M and N, the other one is M1, M2. And now the word symmetry, symmetry means when the line divides it into two equal halves. So symmetry would be a line, okay, a symmetrical line means a line which divides it into two equal halves. Now if you place a mirror here, an object here, okay, if you place an object here, then the image formed will be 360 degree divided by theta. Theta is your angle formed between them, whatever angle will be they inclined. And if it is in symmetry, that is exactly in between the bisector, then the number of images, whatever you find n, you have to subtract 1 with it. Okay, this is when the object is kept at symmetry. And if you keep it at asymmetry means somewhere here, not exactly at the line which bisects it into two halves, but somewhere around. Okay, like this line does not divide it into two equal halves. Okay, so if you keep it in asymmetrical position, then n will be given by 360 divided by theta. And then for asymmetrical values, for asymmetry objects which are kept at asymmetry, n will be n only. You don't have to subtract it with minus 1. Now if you are confused, let's see this. Say there is two mirrors. Okay, two mirrors which are inclined. Two mirrors inclined at an angle 60 degree, and if it's in the symmetric position, okay, if it's in the symmetrical position, then n will be given by, that is the number of images formed will be 360 divided by theta, which is 360 divided by 60. So how much do we get? We get 6. But this is not the number of images. Okay, the number of images will be n minus 1, which is 6 minus 1, and that is your 5. Now same, if the same angle, if the two mirrors are inclined at an angle of 60 degree, and if they are in asymmetry, that means not exactly in the line which bisects them, then n will be given by 360 divided by theta, which is 360 degree by 60, and that would be a 6. So what is the number of images formed? Number of images formed will be 6. Okay, so this is how we find the number of images formed between two plane mirrors. Okay, this is how we find the number of images formed between two plane mirrors. Please remember that. Okay. And if you have any doubt, if you did not understand this part, please do feel free to text or call, and I'll be happy to explain you. Thank you and have a good day.